materials available either from your dealer or through like the North Central Region Bulletin. So as we're irrigating, we've talked about how to get the water out there. Now, how long do I leave it on, or how much water do I put on? And we want to think about our soil as being the bank, the piggy bank. And our rooting depth makes up how big our piggy bank is. And our soil type makes up how much it can hold within any surface area or within any given volume of soil. Our plant's going to be removals, like the checking account, or I'm writing a check out to pull money out of the account. The plant's going to do that on a daily basis. We talked about that earlier. That's going to be evapotranspiration. Nasty thing about this piggy bank is if I overfill it, I lose it. And as I lose water, I potentially soak nutrients out that I paid for to put in there. And they become something that was an asset to me, becomes a nutrient potential contaminant to our groundwater. Soils are not all coated equally. Here's some of the more common irrigated soils. And if you notice, Sphinx soil in 24 inches has almost half what Cibois, one of our sandier loam soils, has. So some of our soils that we're irrigating are going to have double the capacity, the equivalent of 2 inches or 4 inches of rainfall, depending on what soil I have. We talked about plants pulling out water out of the bank account, that writing the check, that evapotranspiration. Here's a graph of green beans, soybeans, potatoes in blue, alfalfa. Notice the alfalfa line has breaks in it. That's because we harvest alfalfa and you go from using a lot of water to less. And what they're talking about here is how much water that plant is using each day. Notice all of these plants peak out during the middle of the summer, somewhere between 0.2 and 1/4 inch a day. So we're going to need an inch of water every 4th or 5th day to feed these plants. Back early on, they figured out that if we raised plants in a box over a scales, that as they used water, the soil being weighed would weigh less, be less by the amount of water being used. If we kept the water adequately so the plant had all the water it wanted, and we actually drained any drainage off the bottom, we could extract it out. And when we got done, we knew how much that happy plant could use for water. And since then, they've indexed those numbers against the major factors: net radiation, temperature, wind speed, and air humidity, and figured out that what we call a standard coefficient of water use. If we say we would need to do 1/4 inch of water every day, or 4 inches a day, or 4 inches in 5 days, that's equivalent to about 5 gallons per minute pump capacity per acre that we're going to irrigate. So if I had a 10-acre field, I'd need at least 50 gallons per minute per pump capacity. On the hottest, driest day, you're going to need to run 24/7 to meet the water needs of that crop. So that's how, or if I had a 100-acre field, I'd need a 500-gallon-a-minute pump. And in 2012, during the peak of the drought, I would have to run it 24/7 to keep up. Some of you are going to say, well, I don't irrigate the whole field. So what we need to do is figure out how much water I'm getting to an area and how much is being used, and do the calculations. To save time here, I'm going to just say, in this case, they're looking at blueberry trees, and they've converted it over, and they've said basically, or blueberry bushes, I should say, that if they're 4 foot wide and 100 foot of plants, we're going to need something like 25 gallons to equal 1/10 inch of water. So if I need 2/10 inch of water today, each of those plants are going to need 50 gallons. So that amount of water ends up being the amount that would need to be applied to make up for what the plant used. Some of you are going to want to get a little more specific. And one quick way of doing that is National Weather Service is now publishing a daily and weekly map. Here's the weekly map. Here's that Michiana area, and it looks like we're using about 1.1 inches on their reference. Their reference is 6-inch grass. That week they had no rainfall, so I've got to irrigate enough to meet that whole reference CT. But I don't raise 6-inch grass, I raise blueberries. But luckily somebody done the work and found out that blueberries use the same amount as grass. So my coefficient is 1, so I'm going to need to add 1.1 inches. If I was early in the season, you notice there I'm not on the curve. I'm not going to be at that 100%. I'm going to be lower. And then late in the season, I'm going to be lower than 100% also. But what we're doing is we're saying, okay, this is what 6-inch grass uses. I'm going to use a K sub C to convert it to my crop. And those K sub Cs are available on the web. Do a quick look. Most of the literature specific to your crop will have a crop coefficient or K sub C. Some of you are going to say that was too complicated. I just want a quick chart. Here's a quick chart. If you're using full sunlight, it's 85 degrees, middle of the season, about late June, you're going to use 0.2 of an inch. So I'm going to need a 1-inch application each week. So those charts end up being a quick and easy way of getting a number, not quite as accurate. Yes, we have more complicated computer systems. If you're just getting started, it's a little bit more of a challenge, but here in the pink line is the daily water use and where we're at. Notice the blue line is where we'd like to say we're full. If I overfill, I leach and I have losses. That's these red points where between rainfall and irrigation, we overdid it, we lost some. We had some nice rains here and these blue dots that helped us keep in the region, but I want to stay so I do not over irrigate, but I want to avoid wilting. Wilting's the point where the plant can't keep up, can't get enough water to stay turgid. It rolls up or flips its leaves or does some other mechanisms to stop its water loss. So we want to stay between the wilting point and the full line. And there's some nice computer programs available. We could talk about those or find them on our website if you need those. Most of you working with trickle tape are going to develop during the winter time, whatever tape that you have, put together a chart of how many minutes each run needs to be. So here's some common ones put together by Dr. Goldie up at the research station. And he's figured out his bed width for his most common drip tapes and how long he has to run to be the equivalent of 1/10 of an inch all the way up to 1/2 an inch to make those out. Once you've got that math done, it makes it a lot easier during the peak hard work time of the summer to figure out how many minutes I need to run each line to get that amount that's up there. As we're finishing up here, some of you are going to say, well, let's move on to the electronic age. Let's start looking at actually measuring the soil, the moisture in the soil. We're doing more of that. If you look at that top chart, you'll notice that 6 inches. Every time you do an irrigation application, you fill that profile up, and then the water that's remaining goes down. So that red line goes up and down because it's where the most roots are. It dries out quick, but it refills every time we irrigate. The blue line's going to be that 24-inch line. Notice it's the most stable, and it gives us an indication of where we are as far as things, but it's moving much less each day. And then in between is probably where we really want to look at our management. We want to see that in between line moving up and down, but not major change.